Hello, we are going to study structure of atom. The first atomic theory of matter was proposed by John Dalton, which is known as Dalton's atomic theory. He proposed that matter was made up of smallest and individual particles called atoms. But some researches done by some researchers have established that atom is not the smallest individual particle but had a complex structure of its own and was made up of still smaller particles like electron, proton, neutron, etc. At present, about 35 different subatomic particles are known, but the three particles, namely electron, proton, neutrons, are regarded as the fundamental particles. So, our first topic is discovery of fundamental particles. First particle is electrons. Discovery of electrons by J.J. Thomson. He utilized Faraday's study of electrical discharge in partially evacuated tubes known as cathode ray tubes. So what is the cathode ray tube? Cathode ray tube is the cylindrical hard glass tube fitted with two metallic electrodes connected to the oppositely charged poles of a battery and connect a vacuum pump. Here battery use of high voltage 10,000 volts. So cathode ray tube, it is the tube where two electrodes are connected with the battery. Here is a vacuum pump. It regulates the vacuum. Which electrode is connected with the negative pole of battery is called cathode, and which electrode is connected with the positive part of battery is called anode. It is also known as positive electrode, and it is also known as negative electrode. So rays are traveling from cathode to anode. The question is here arises, how can we say that rays are traveling from cathode to anode? So we can confirm by this: a glass tube, a anode, here anode possesses holes, some small holes, and beyond the anode, glass tube is coated with fluorescent. Fluorescent coating, like zinc sulfate, and this anode is connected with the battery, positive pole of battery, and here is the cathode, which is connected with the negative part of battery and vacuum pump. So when the rays traveled from cathode to anode, so rays passes through these holes and strike on this surface, and there strike the rays and glows the fluorescent coating. So we can say that the cathode rays are traveling from cathode to anode. That's why this is known as cathode rays. So further, Various experiments performed by J. J. Thomson on this model, uh, and he stabilized some properties of cathode rays. First is the glass tube where he put the object in the glass tube. Here is the cathode. Here is the anode. When the rays travels from the cathode to anode, so here shadow is created. So he can stabilize that cathodes they are traveling from cathode to anode, and second experiment is where he connected a paddle in the glass tube. Here is the cathode, is the anode, and connected with the battery. When rays are traveling from cathode to anode, then the rays strike on this pedal and pedal starts the rotating, which proves rays having some mass and these mass having some velocities. That's why this mass is moving from cathode to anode. And this his third experiment. He connected a electric plate to create the electric field, the positive, negative, anode, cathode, and both electrodes are connected with the battery. When the rays are travel from cathode to anode, it deflected toward the positive plate, which means these mass having negative charge. Due to this, it is deflected toward the positive plate of electric plate. Then he performed many experiments and proved some properties like cathode rays have moves from cathode to anode. Cathode rays produced heating effects. Cathode rays do not depend upon the material of the electrode and the nature of gas taken in the discharge tubes. Means cathode ray does not depend on the material of electrode and nature of the gas which is in the glass tube. And now we have to study the experiment of J. J. Thomson. It is the J. J. Thomson model. He his his model was, here is the cathode, is the anode, which anode has having small hole, and it is connected with the screen. It is the fluorescent screen, and he connected here electric plate, positive, negative, and here a magnet, the north pole, the south pole, anode, cathode. It is connected with the battery, 10,000 volt. So when the cathode is traveling from this hole, is stuck on this surface. He performed this experiment in the three conditions. First, when the only electric field is applied, no magnetic field applied. So when the only electric field is applied, then the cathode ray deflected toward the positive plate of electricity, and this ray is stacked on this surface and known as A. And second, performance the on the absence of both fields. That means no electric field, no magnetic field. Then rays are goes straight and stack on this surface known as B. And third is on the applied of magnetic field. No electric field is applied. Then rays are deflected to according to the magnetic field and stack on this surface known as C. Actually, here they apply the Fleming's left hand rule, where it represents the force, this represents the magnetic field, it represents the current or moving charge, and uh, these fingers are perpendicular to each other. Means these three are properties and perpendicular to each other. So when the is magnetic field is applied toward the north to side south, and rays are traveling from this surface, then force is applied downward. So rays are strike on this surface. So what we get? We get only presence of electric field, electron hits the screen at point A, and only presence of magnetic field, electron hit the screen at point C, and absence of the both fields, electrons hit the screen at the point B. And he determined the ratio of E upon ME is equal to 1.75820 into 10 की power 11 C. C here is the coulombs, unit of the charge per kilogram. E is the charge of electron, and Me represent the mass of electron. And a scientist, Millikan, he performed a experiment which is known as oil drop method. We find the value of E, means charge of electron, by his experiment, and value of E is 1.6022 into 10 की power minus 19 coulombs. So when we put the value of E in this ratio, so we can calculate the mass of electron. E by Me is equal to 1.6022 into 10 की power minus 19 is equal to 1.758820 to the power 11. It Here the unit coulomb is the unit coulombs per kilogram. Then we calculate the mass of electron and we find that 9.1094 into 10 की power minus 31 kilogram, and density of electron is 2.77 to 10 की power 12 gram per ml. Radius of the electron is equal to 4.28 into 10 की power minus 14 centimeter.